So I can fill this in. I can find cosine of 30 degrees from that right triangle. That would be the x-coordinate, and then the y-coordinate is going to be sine of 30 degrees, which I can also find from that right triangle. So just note the relationship between the circle and then right triangles to come up with these coordinates on the unit circle. So looking at the 30, 60, 90, and again, you can ignore those x's or think of them as ones, because as you do one side over another, the x's would cancel out anyway. So for 30 degrees, cosine is adjacent over hypotenuse. So the adjacent side would be square root of 3. Hypotenuse is 2. That means cosine of 30 is the square root of 3 over 2. And you can use the line that's given there as the fraction line if you'd like. So that's the x-coordinate of that point, cosine of 30. And then sine of 30 would be the y-coordinate. And sine is opposite over hypotenuse, so the opposite is x, so that would just be 1 over the hypotenuse is 2. So the y-coordinate is 1/2. So that ordered pair is square root of 3 over 2 for x, 1/2 for y, because it's cosine of 30 and sine of 30. Questions on that? Okay. So then I can do the same thing for the 45-degree angle. So again, that means between that terminal side and the x-axis, that angle is 45. If I drew in a right triangle, drawing a vertical line down from that point, I would have a 45, 45, 90 triangle. So I can use the 45, 45, 90 to find cosine of 45, sine of 45 to get my x and y coordinates. So I'm just going to use, since they're both 45, I'll just reference this one. I'm thinking of both legs as having a length of 1, since it's just x, and then the hypotenuse is square root of 2. So cosine of 45, which would be the x-coordinate, is adjacent over hypotenuse. That would be 1 over the square root of 2. But I don't want to write 1 over square root of 2 here. I'm just going to write this down. Cosine of 45 is 1 over square root 2. I should simplify that before I write it in. I'd have to rationalize that denominator, so multiply by square root of 2 over square root of 2. So it'd be square root of 2 over 2. And then sine, which would be the y-coordinate, sine of 45 degrees, is opposite over hypotenuse. So because the opposite and adjacent are the same length, that's also going to be 1 over the square root of 2, which will simplify to also be square root of 2 over square root of 2, or square root of 2 over 2, sorry. So at 45 degrees, that ordered pair is square root of 2 over 2, square root of 2 over 2. Sine and cosine have the same measure at 45 degrees. So these are, and I know we've worked before with finding exact values of trig functions, because aside from the 1/2, these other values, if you just type them in your calculator, you're going to get irrational numbers. You get decimals that are not repeating decimals, and that's because there's square roots in those values. So again, thinking ahead to trig next year, you will be expected, if you ever need cosine of 30 degrees, to give this value and not type it in your calculator. You'll just have to know that or know how to find it. And then the last one in this quadrant, 60 degrees. So from that terminal side to the x-axis, that's 60 degrees. If I drew a right triangle in, it would be, again, a 30, 60, 90. So when I'm looking at the 30, 60, 90, I'm focusing on the 60-degree angle. X-coordinate is cosine of 60. So for the 60-degree angle, the 1 is the adjacent side. Hypotenuse is 2. So now cosine is 1/2. And then for the 60-degree angle for sine, opposite over hypotenuse, the opposite is the square root of 3 over the hypotenuse is 2. So because, just based on that right triangle, because the opposite and adjacent switched, depending on which angle you're referencing, just notice between 30 and 60, the x and y coordinates, or the cosine and sine values, just switch. Okay, so any questions so far on how we came up with these coordinates? Okay, so you've done already, by coming up with these, we've done most of the work to now be able to fill in the rest of this, because, so I'm going to help you out here and help you understand too, where these other angle measures are coming from. So I'm going to start with, I'll start with the 30 degrees. So notice this line here at 30 degrees and this line here. If I go around the unit circle, so if I go up 30 degrees, I'm at 30. If I go another 30 degrees, I'm at 60. If I go another 30 degrees, I'm at 90. So it's splitting it into increments of 30. So if I go another 30 degrees, I would be here, and that means this angle is 90 plus 30, so this angle would be 120. I'm skipping over the middle one, but if I go another 30 degrees, I would be at this angle, and 120 plus 30 is 150. And then going another 30 degrees would bring me to the 180. Okay, so I'm stopping there. I have 120, I have 150, and then for this middle angle, that's kind of based off of this 45. So I can also break this unit circle into increments of 45 degrees. So if I go 45 degrees, I'm at 45. If I go another 45, I'm here at 90. So this angle here is just another 45 degrees past 90, which is 135. 90 plus 45. Or it's halfway in between, exactly halfway in between 90 and 180. So now to fill in these coordinates, what we're actually going to be using is reference angles. So I'm going to start with the 150. What is the reference angle for the angle 150? What would the reference angle be? 30. Yes, the reference angle would be here. The distance between 150 and 180 is 30. So I'm just going to make note up here. That means if I'm trying to find cosine of 150 to get this angle measure, cosine of 150 would be equal to, this is something we've already done in 12.3, would be equal to cosine of its reference angle, which is 30. I do have to think, though, if I'm in quadrant 2, is cosine positive or negative? Negative. What's positive in quadrant 2? Sine. I'm just going to make a note, in quadrant 2, sine is positive. I could have also put quadrant 1. We didn't have to worry about all of them are positive in quadrant 1. So I'm going to just stick a negative sign here because cosine of 150 will be cosine of 30, but it's going to be negative. I already found cosine of 30. That's square root of 3 over 2. So that means this x-coordinate is just the opposite of that. This x-coordinate is just negative square root of 3 over 2. All right, but then hopefully you see then, with the reference angle of 30, I can do the same thing for sine. Sine of 150 degrees will equal sine of 30, and sine is positive in quadrant 2, so it'll stay positive. Sine of 30 was 1/2, so sine of 150 is also 1/2. Okay, so the ordered pairs that you came up with in quadrant 1 will repeat around the circle. You just have to pay attention to what signs everything should be. Should they be positive or negative? So let's go to the angle of 135. What is the reference angle for 135? 45, yep. So from 135 to 180, that's 45 degrees, meaning these coordinates are going to match the coordinates at 45 degrees because it's the reference angle, except the cosine value should be negative, the sine value should stay positive. So this x-coordinate is going to be negative square root of 2 over 2. This y-coordinate is positive square root of 2 over 2. Because 45 degrees is the reference angle. Then you can probably guess what's going to go in at 120. From 120 to 180, that reference angle is 60. So those coordinates should match. But again, the x-coordinate cosine should be negative. So x would be negative 1/2, and y is going to stay positive square root of 3 over 2. Okay? Questions on how I got what's in quadrant 2. Just kind of figuring out what goes where. But once you have one quadrant, you just kind of see how that fits into the rest. What I'd like you to do is I'd like you to try filling in the remaining half of this unit circle. Okay, so I had gone through how I got these 3 angle measures and then also how I got these coordinates. So I'd like you to try this. I will make sure at the end, so I'd recommend writing in pencil if you can, because at the end I do want to make sure you have it filled in correctly. So we will compare. I just want to make sure if you did get something wrong, you're able to change it so what you have is correct. I'll give you a few minutes. I will walk around. I can check things. I can answer questions. Help each other out. Okay, I'm going to show what I have double checked, especially some of the last groups. I just made sure you had a chance to fill it in, but make sure you have it filled in correctly. So first of all, look at your angle measures. Make sure you have 210, 225, 240, and then 300, 315, 330. And then for your ordered pairs, I'm not going to read these off, but make sure in quadrant 3, both x and y should be negative. Both cosine and sine are negative. And then in quadrant 4, only the y coordinate should be negative. The x's should be positive since cosine is positive. And then double check that you have the values in the correct places. Okay, so my hope is that when you see this next year, I realize there's a summer in between and you don't start out right away with the unit circle day 1 of trig, but my hope is that when you see this next year, you already have an understanding of how all of those numbers are placed on the unit circle. I do want to fill in the radian measures as well to help give you a better understanding of radians, because working in radians is like working in fractions. So in these other blanks by the degree measures, we're going to put the radian measures. So next to 0 degrees, I know that's 0 radians. How many radians if you go all the way around? 2 pi. So 360 degrees is 2 pi radians. Therefore, halfway around, so I'm just trying to show you how this is broken into fractions. So all the way around is 2 pi. So halfway around, which would be 180 degrees, is 1 pi, or just pi. Half of pi, which would be the 90 degree mark, is 1/2 pi, or pi over 2. And then I'm also going to do the angle at 270. So from 1 pi to 2 pi, halfway in between would be 1.5 pi, but that's normally written as 3 pi over 2, since 3 over 2 is 1.5. So 3 pi over 2 is how that would be written. They're written as improper fractions versus mixed numbers. Okay, so now labeling the other angles, because again in trig, this is really a preview for that. We had already, I know it was in a previous section, we had converted the 30, 45, and 60 degrees into their radian measures. So just knowing that you could convert these, actually we might as well look at doing that. So if I have 30 degrees, maybe I'll just do that on the board here so I'm not taking up space on my sheet. How do you convert a degree measure into radians? Or multiply, yeah, or multiply by pi over 180. So I could put this over 1. All right, and then the degrees cancel out. I can divide 80 by 30, so this is 1. I can divide it in at 6. So 30 degrees is pi over 6 radians. So that radian measure is pi over 6. And actually, I'm going to stop there for a moment, because remember, between the 30 degrees and the 60 degrees, some of the degree measures, it's as if you're going around by measures of 30. So if I went 30 degrees, that's equivalent to 1 pi over 6. So if I go another 30 degrees, which brings me to 60, that's 2 pi over 6. But 2 over 6 reduces to 1 over 3. So this is pi over 3. it would be 2 pi over 6, but that's pi over 3. If I go another 30 degrees, that brings me to 90. That would be 3 pi over 6, and 3 over 6 is 1/2, so pi halves makes sense. If I go another 30 degrees, that brings me to 120. That's 4 pi over 6. 4 over 6 is 2/3. So this would be 2 pi over 3, 2/3 pi. If I go another 30 degrees, that's 150. That would be 5 pi over 6, and I can't simplify that. And then another 30 brings me to 180. That's 6 pi over 6, which is just pi. Okay, and I keep going. So notice I'm just going around by basically 1/6 each time. So another 30 degrees brings me to 210. That would be 7 pi over 6. Another 30 degrees brings me to 240. That's 8 pi over 6. 8 over 6 is 4 over 3. So that would be 4 pi over 3. Another 30 degrees is 9 pi over 6. 9 over 6 is 3 over 2. So you can see how that simplifies there. Another 30 is 10 pi over 6. 10 over 6 is 5 over 3, so 5 pi over 3. Another 30 degrees would be 11 pi over 6. That can't be simplified. And then the last 30 degrees would be 12 pi over 6. 12 over 6 is 2, and that's why it's 2 pi. So really, you're just breaking that circle into fractions. It's like you're going back to maybe when you first learned fractions and you were taking fractions of a circle. That's kind of what this is. Okay, and again, this is a preview, so you're going to be seeing a lot more of this if you take trig next year. Then the remaining blanks are at the 45, 135, 225, 315. 45 degrees, I'll just show this quickly so we can get to the homework quiz. If we converted that, or actually let me ask you this. What fraction of the circle do you think 45 degrees represents? What fraction? 1/4, yes. So 45 degrees would be 1/4 of pi, or pi over 4. Another 45 degrees would be 2/4 of pi, which is 1/2. That means this is 3/4 of pi, so 3 pi over 4. 4/4 of pi is just pi. 225 would be 5/4 of pi, so 5 pi over 4. 6/4 of pi is 3/2. And then 315, the last one, is 7/4 of pi, 7 pi over 4. 8 pi over 4 is 2 pi. All right, so that is the unit circle filled in to help you make sense. So I could have just given you that, but you wouldn't have known where that information came from, okay?